course, last time we finished up with arrays. And arrays we kind of saw were kind of like lists, but you know, you index them like lists. You can assign values to specific indexes like lists, but unlike lists, arrays, you can't just arbitrarily append to the end. They don't grow dynamically. If you create an array of size 10, it's always going to be size 10. You can't change that array. Okay, input, output. So we already saw output. Writing to what we would call standard output. In Python, we did this with print. In Java, we do it with system.out.print, or print line. Print ln for print line. So that's output. Same idea. It's just, well, you call a specific function that prints. In Python, it's called print. In Java, it's system.out.print. Input, on the other hand, is a little annoying. So one of the biggest criticisms of Java is how verbose it is. And sometimes it feels like, you know, I just want to do this one thing, and in order to do that in Java, I have to jump through 100 hoops to do it. It's kind of a pain. You're right. And oftentimes, it's situations where you're trying to do something that Java wasn't designed with that in mind. That's not a good way to word it. Python, scripting language, designed for easy, reading in, reading out, doing whatever, quick I/O, easy peasy, right? Because that's a big part of what the language is for. Java, entirely do that, but one of the considerations for Java when Java was being designed was not so much that. You could totally do it, but it wasn't something that was designed to be, it wasn't a huge core principle of the design, let's say, for lack of a better term. I've explained it poorly, but the point is, this is a pain in the ass in Java. That's the point. So probably the most common, I don't know if that's even right. Most straightforward, I don't know if that's right either, but a really nice way of reading input in Java is, well, like this. So first, we want to read from what we call a stream. A stream is just like a stream of information that could be coming along, right? So first thing we do in Java is you create an input stream reader. And note for a moment that, of course, the class details and the public static void main string args is excluded here for brevity. But if we go here, I'll zoom out. That's even worse. Let's scroll to the side. There. We're going to create an input stream reader. So we're creating a stream reader, an input stream reader. And that's an object, that's a thing that we can use to read from a string. Read from a stream. And when creating it, the parameter is system.in. System.in is reading from standard input. System.out is writing out, in. So we're saying from standard input, with using standard input, create an input stream reader. Now an input stream reader, in and of itself, isn't that nice to interact with. But what is a lot nicer to interact with is a buffered reader. So we create a buffered reader, and we give to it a input stream reader that I call stream. Then I can use the buffered stream reader, which has a lot of nice handy methods built in from reading it, like readLine, for example. So I call reader.readLine. Well, because I've got my buffered reader, which is an instance of a buffered reader object, and that's the method I can call on it. What I will say about this is, if 20 minutes after lecture you came to my office and said, how do you read from standard input? My answer is going to be like, I don't know, look it up. Because I haven't committed this to memory, and really you shouldn't worry about that either. It's that type of detail that's not overly important here. It's just, here's how you do it. And when you have to do it, if you have to do it, you can go to this website. Or you could just remember that, you know, I remember him talking about it, reading from standard input. Google that, oh, there's a solution. The point of what I'm saying to you right now is, it's kind of a pain, and when you got to do it, just re-look it up. Don't try to memorize this, it's crazy. Now, you might remember in Python, okay, so right now, here we've got input stream reader. Here we've created the buffered reader, which took the input stream reader because the buffered reader makes it a little nicer to interact with. And you might That's where we are. We haven't read anything yet. It's just we created the stuff we need in order to read from it. And by the way, the reason I'm showing this particular strategy of reading input is you could do basically the exact same thing to read from a file, except instead of reading from system in, you're reading from a file. So it's like the same, it's just you specify what you're reading from, which is kind of nice. But anyways, all we've done as of now is prepped for reading. It's the code inside the try that is doing the reading, which is effectively the equivalent of this. This is what we did in Python. This is ultimately what we wanted to do. In order to do that in Java, we need all that set up, and then wrapped in a try is the equivalent code. Read the line, print out the line. Read the line, print out the line. That's Python, Java. That's what's equivalent here. But Java has a lot of that extra stuff we need. It's very verbose. The reason it's wrapped in a try catch. So you remember in Python, exceptions. Same thing in Java. But what's cool here, so like in Python, the code could throw an exception, and you know, just because the code threw an exception, you didn't even need to like acknowledge it. It could happen, you know, and you were just aware that if I call this function and it throws an exception, well, tough for me. We didn't hit a lot of cases like that last semester, but whatever. That's how it would work. In Java, there's a way for the programmer of the function, of the method, read line here, in reader.readLine, in that method, if we go look it up, there's a way that the programmer can raise an exception, throw an exception. In Java, we call it throw. In Python, we call it raise, whatever. It's just a keyword, same thing. There's a way for them to say, okay, something funny might happen. Remember, the whole point of exceptions wasn't necessarily that it's a bug or something, but something peculiar happened when using this method. That is atypical. So it's an exceptional situation. And so I'm going to raise an exception, and then the programmer using my code that might raise an exception has to deal with it if the exception is raised. But Java, giving more tools and control to programmers, it was written in such a way that when this code raises an exception, it forces you, as the programmer using that method, to explicitly say what you want to do about the exception. So Python could raise the exception, the programmer would decide what they want to do. Same thing in Java, but me as the programmer writing the original method that can throw the exception, I can make it so you have to write what you want to do if that exception is thrown. And the point of that is, it makes the code much safer. If an exceptional situation happens and you ignore it, weird undefined behavior can start happening in your code. In Java, if I make it where like an exception could happen and you have to explicitly write what you want to do about it, even though 99.9% of the time people are probably going to want to ignore it, just carry on, move on, that's great. Write that code to explicitly say that that's what you want to do. It makes the code safer. So we wrap it in a try catch. This isn't going to happen very often in the course, but it does. So we see try to read from the reader. If it worked, great. And then immediately print out the line, the line. Print out the string, the line. If everything worked fine, carry on. But if, for whatever reason, an IO exception was raised, it gets caught, and we just print out, well, something bad happened. And then we carry on either way. Yeah?
What's an example of it, like, why it wouldn't work?
Why it wouldn't work? So particularly here, with IO exception, so this is, of course, this buffered reader is more general. So this could be something caused by like a corruption with a file, if you're trying to read from a file. There could be a lot of cases. It could also be some other code that might have like a divide by zero error or something. Like, well, what happens if someone calls this function or this method and it divides by zero, right? So there could be an exception. So if you're using that method and somehow that method tries to divide by zero, what do you want to do about it? And you have to explicitly say. Now, the way of writing this here, this right here is the typical way you would write this code, try, catch. But because we just so happen to be writing code in the main method, it's not uncommon to basically cheat and just add this throws IO exception in the signature. So then if we scroll down, we eliminate the need for the try catch. Because by adding throws IO exception, What that means is, okay, look, some code inside this method, in this particular case it happens to be main, might call code that raises an exception. And if that exception gets raised, I have to deal with it. But sometimes it just so happens in the way that you've written your code, you really don't want to deal with that situation right then and there. So what you do is if you put throws IO exception in the signature, that tells Java like, okay, if an exception happens, you're not going to deal with it here, but this method is just immediately going to just pass the buck to the next one. So I'm the method someone told me to run. I call another method that threw an exception. I get an exception. I'm supposed to catch it and deal with it. But for whatever reason, me as a programmer is specifically saying like, no. I'm not going to, like, this method's not going to deal with it. This method's just going to propagate it and be like, okay, whoever called me has to deal with it. And we can do this all the way up to main, which this is main. So the reason that doing it this way with main is not so atypical is, you know, I want to just read a line. And if an IO exception happened for this particular program, I don't give a shit. It doesn't matter. It really has no consequence at all. So if it just so happens that an IO exception is raised, and if that exception is raised, that method is just going to propagate it to the calling method. Now, in this particular situation, this is main. There was no other method that called main. You called main. When you hit run, you invoked the main method. So it just throws the exception back at you, thus crashing the program, which is kind of what we would want to have happen here anyways. I gave you a lot of detail there that's not overly important right now. I'm just showing that with the throws IO exception, because it's in main, and often we always just want to do our IO in main anyways. You might remember last semester we kind of avoided like reading input or output within other functions. It always kind of happened outside the functions, and you would pass that details to functions. We would do the same idea here in Java. So by saying throws IO exception, it's a way to be like, yeah, I don't want to write the try catch because I really don't care. But by me writing throws IO exception, it's a way of me, the programmer, acknowledging that yes, an exception can get thrown that I have to deal with. So I had to explicitly write throws IO exception to make Java happy before it would even start to run. Because Java has a lot of tools to enforce that the code is used correctly. So this right here, but the throws IO exception, like if I'm doing it, I'm writing it like this. But the throws IO exception, because I don't want to do the try catch stuff, it's annoying. So yeah, this just passes the buck of dealing with the exception to the caller. In this example, it's the main, so it throws at the person who ran the program, and it would crash the program. Great. Questions about that? Now you asked about scanner. And scanner is an entirely different way of reading from input as well. And there are other ways of reading from input as well. They all have pros and cons. They're all a little different. Why would you use one over the other? It depends on the situation. Depends on which one you like. Whatever. Methods and functions. So, you remember, in Python we wrote functions. They're great. But then when we learned about objects, classes and objects, we learned about methods. Every function we wrote inside a class was actually really a method. Because what you would do is, if I had an instance of that object, I would call a method on that instance. For example, if I had some list in Python, and I wanted to append some number to that list, I would say, mylist.append. So I called that function, we call it a method, on the instance of that class. Remember that? Java's funny because every single thing we write is within a class. Meaning everything we write really is technically a method. But we have a special keyword called static. And static is a keyword we use when defining something to say this doesn't belong to an instance of this object, of this, like it doesn't belong to any instance of this class. It's just a method or a variable. So, for example, here, let's look at Python. Here's a function in Python, def some function a, b, We sum it, return the value, then I call the function with 1 and 2, get the result, and print out the result. Here's the same thing in Java. It exists inside some class. I've got, it's called some class, that's arbitrary. I've got my main right there, that's also static. And then below I've got static int, some function, int a, int b. So, parameters for the functions or methods have to include the type, just like the variables. So this is saying, okay, some function is a function that takes 2 parameters, 2 integers, which is nice. Because if I look at some function ab over here on the left, is that supposed to be integers or strings? How do you know? On the left, how do you know?
Oh.
You don't. This is a huge criticism of Python, is you look at this code and go like, well, this is a function that takes 2 parameters, a and b, and you'd be like, yeah, but what are they? And you go, I don't know. Because what would happen if I gave you, if you called that function, some function, with the number 1 and 1, what would you get back in Python? 2. What if you called it with 2 strings? 1 and 1. The string 1 and the string 1. What would you get? 11.
The string 11.
The string 11, that's right. Suddenly you're left going like, what the hell? Imagine you read input and you forgot to convert the input from a string to an integer before calling this function. You read the input and suddenly you see 1 plus 1 is 11. You're left going like, what? You try to do that in Java? Java won't even compile. Java will say, IntelliJ will even tell you that you've got a mistake before you even try to compile. IntelliJ will be like, this function you wrote that takes 2 integers, you gave it 2 strings. That's not going to work. You've eliminated a bug before you even became close to hitting run, which is fantastic. So you explicitly say int, and now me as a programmer go, oh, well that's a function that takes 2 integers. And then inside of it, it creates an integer c, it's the sum of the 2, a and b, and then we immediately after return c. Of course that could have been done in 1 line of code, but whatever. Now, what is the return type? If I add 2 integers together, what type do I get back? This is not a trick question. An integer, an int. So when I say return c, this function is returning a value, but the value has a type. And just like when you were defining the variables where you have to specify the type, you have to specify the return type of all your functions or methods. So, static int means this function is going to return an integer. If we look at main, we see static void. Void is a special case where, well, sometimes you've got a function that just doesn't return anything. And if your function isn't returning anything, you put the word void. But often we've got our types, right? So this function's return type is integer. It's static, which means we don't need to have an instance of a some class object in order to call this method. Let me be more clear about what that means. No. So, here, let me make sure I didn't miss anything here. Int ab, static, some function. You'll notice I didn't include the word public here. I probably should have, but doesn't really matter in this particular example. Okay, you know what? Okay, we'll hit instance methods and then we'll go into, come on, do I not have an example of the difference? Maybe it was in the previous topic. Here. Give me one moment. I want to see if I can find that nice intro. Yes, here we go. This is what I wanted to show. So this right here. For example, look. Ignore line 2 for a moment. Look at lines 5 and 6. Line 5. I'm creating an instance of a some class object. The syntax for this is remarkably similar in Python. Just in Python, we don't need to specify the type of the variable, right? So here the variable is an instance. And I know it's going to be of type some class. Python, I wouldn't have needed to specify some class. And in Java, we use the new keyword when we call the constructor, and you call the constructor by just calling the name of the class that you want to create an instance of, that was the same in Python. It's just you wouldn't use the word new. This creates a new instance of a sum class object. What is a sum class object? Doesn't matter right now. It really doesn't matter. It's just, I've created an instance of an object. Just like how you can create an instance of a list. Or in assignment 4 and 161, you created an instance of a country, right? So we've got an instance of a country. And then I want to call a method on that specific instance. Maybe I want to get that specific instance name. Hey, country A, what's your name? Country B, what's your name? They're probably different. They both have names. But when I call country A, get name, it's going to give me its name. And country B, get name, it's going to give me their name. So here's an example of I've created an instance of a sum class, and then I call the method sum method. What does it do? Doesn't matter. But the point here is I've got an instance of a sum class, and I call it by saying instance dot name of the method, right? This worked the same way in Python, just slightly different syntax. Slightly. But when you wanted to call a function, you never needed an instance of it, right? You could just call the function, like print. You didn't need to say in Python, some output object dot print. You just called print, because it's just the function print. So, same idea. When you say static, it's a function. When you don't say static, well, that means that that method is going to belong to an instance, and in order to invoke it, you need to have an instance of whatever that object is in order to run it. This will be much clearer once we sink our teeth into actually writing our own class, which is the next topic. This will come back to you pretty quick, I bet. Any questions, though, about that? No static, you need an instance of an object to call it. Static, you don't. And a good example of this is if we go to math. Remember in Python if you wanted to do like cosine, right? You would import math, right? And then you would say math dot cosine. And in the math library, you are calling the function cosine. And why was cosine in the math library? It makes sense to put it in a library with a bunch of other math operations, right? Someone put it there, and it just kind of makes sense. Good bookkeeping. Well, in Java, I could call math dot cosine as well. But math is where it's stored. And I can actually click math like this, and it actually takes me to the math class. But notice that I'm calling, like if I control F in here, cos, there's the cosine method. It just calls another thing called strict math. I don't know the details. But there is the cos method function, really, because it's static, from within the math class. So I'm invoking that one. It's mad because I didn't give it a proper parameter. 0.1. I don't know. Now what's at 1? I'm not doing anything with it. Yeah, it's ignored. Great. But notice that in order to call this function, the static method, in order to call this, I didn't need to make an instance of a math object. I never needed to go math, my math object equals a new math, and then I didn't have to do like my math object dot cos. I didn't need an instance of a math object to call it, because cos is a function, static method, not a method. So I don't need an instance of an object to call it. I just call it. Now here I need to say math because, well, it exists in the math class and I need to tell Java. If I didn't include math, it's going to say where the hell is here. If I say cos of 7, let's try that again. It's going to say, what does it say? I cannot resolve method cos. Yeah, because I didn't say where it was. So if I say math, it's happening. Any questions about any of that? I realize at this stage, we're still in the deep end, and I haven't really shown you how to tread water yet. Once we start writing our own objects, these pieces will probably fill in as we go. This is just giving you an overview of some of the differences.
So you don't have to actually import math.
In this particular case, you don't, but there's a bunch of things you would have to.
Okay.
Yeah. But you're right. And by the way, if you If people are like, how am I going to remember what to import if I need a buffered reader? Well, you don't, because look what's going to happen. Buffered reader as an example. Look, IntelliJ just boom, right there. I didn't even need to write it. I was saying in lab yesterday, back in my day, I had to write it out. Oh, it's terrible. Kids these days, IntelliJ is writing it for you. It's fantastic. Which is definitely not good for remembering where things come from when you depend on the technology. Just fill in the blank, but whatever. Other questions so far? All right. So static, okay, let's get to the instance method. So in Python, if we were within some class that we were writing and we wanted to write a method, meaning I want this to be something I would invoke on an instance of some object, I would say, okay, def some method, whatever it is, and I say self, because the first parameter always has to be self in a method in Python, comma, and then I've got this other one called addme. And what does this do? Well, it does self.some instance variable plus equals addme. So it looks like this is taking some value and it's just adding that value to that instance variable for the class. It's weird, but whatever. It's all it does. And that's the syntax I would use. In Python, if I wanted to do a method, if I wanted to write a method, or in Python, in Java, this is how I write it. Public, assuming I want it to be public. Void, well, this method isn't returning anything, so the return type is void, it's nothing. Name of the method, some method. Mind the syntax, that's the convention, lowercase, but it's it starts lowercase, and then any other word that would follow, there's no underscore, you start with an uppercase. It's called camel case. So the method is called some method. It takes an integer addme, but notice we don't need something like self. We don't, which is nice. And then I say some instance variable plus equals addme. Syntax, remarkably similar, but some nuanced difference. There is a similar keyword in Java as self to Python. You don't need to include it often in Java, where you have to in Python. In Python, you have to say self in a lot of situations. But in Java, there's an equivalent keyword that's called this. And this is a common keyword in a variety of different languages, like C, C++, I'm pretty sure C# as well. I could be wrong, don't quote me on that one. But you could say this. So if I wanted to reference, I could say this.some instance variable plus equals addme, and that would be equivalent. But I don't need it here. Where in Python, I need the self. In order to specify that, this is the instance variable's instance variable. This is the instance's variable. Okay, visibility modifiers. I'm only going to touch at scratching the surface of this. This is gonna fill in the blank. The blanks will be filled in as we go in the course, pretty quickly, I think. So in Python, we have this convention. If anything started with an underscore, it meant you're not supposed to use this outside this class, right? Underscore meant if the underscore preceded a variable, it means this variable exists inside this class, but you're not supposed to touch it directly. If you go back to assignment 4, which you might not remember too much, but within it, in the country catalog had an instance variable of a list that held reference to the various countries in your catalog. That variable started with an underscore because you would use that list inside the class. All the various methods in your country catalog would make use of list, because if you called the add method, well, it needed to add something to that list. Remove from that list. But if you went to something like your main, where you had your country catalog object, I'm not supposed to directly access that variable. It starts with an underscore, and so that convention means, sure, you can access it, but you're not supposed to. Same thing with functions or methods. If you had an underscore preceding the name of the method, it means, this method exists, and it's used inside this class. But if I'm using the country catalog object, if I have a country catalog object, I can call the add, but I'm not supposed to call the find method. The find method started with an underscore. And find was private. I could call it, but I'm not supposed to. The convention, I'd be breaking convention. In Java, we have the same thing, but instead of using an underscore, we use public or private. If it's public, that means it's accessible everywhere. If it's private, it's like you put the underscore in front of it. But unlike Python, when you declare something as private in Java, and you try to access it, Java will say, no, I'm not even gonna try to compile this code because the programmer said that this was private, and someone's trying to modify it, someone's trying to access this private thing, and that's against the rules. So fix this before I even try to run. And we're gonna see countless examples of this as we go. But really quickly, if I go here, I'm gonna create very quickly a new class. Someone give me any word.
Apple.
Perfect, we're gonna make an Apple object. And we're gonna have a public, real quick, int size. I don't know what units this is in, but who cares? So there's gonna be one instance variable, one field for this Apple object called size. I'm gonna write a constructor. We haven't talked about this yet. I'm gonna write a constructor you can observe, but don't worry, we haven't covered it yet. Nope, no. Public Apple. Great. So in Python, constructor is underscore underscore init underscore underscore. In Java, no, it's just the same name as the class. That's what it is. And I'll say size equals size. So what this will do is, and you know what, to remove any ambiguity, I'll say this. I don't need the this, like I would have needed the self in Python, but this helps resolve any ambiguity. When I see this dot size, it refers to the size defined on line 3. I think that's line 3. Line 3. When there's no this, well, it's referring to the size that's defined as the parameter inside this method, this constructor. So it takes the value of this and assigns it to this. Very simple. If I go here and let me make an instance of an apple. My apple equals a new apple. And what size should the apple be? Give me any number.
7.
5, let's do 5, 7 because it's a big one. Right? And now I can access, because this field here is public, I can say s out my apple, so the instance of the apple dot size. And I can run this code, and it's going to say 57. At least it better. 57. Right? It's public. That value, that variable, we call these fields if it's a variable that belongs to an instance of an object. In Java, we call them a field. That field is set to public, meaning I can access it directly from outside the class. Often, we don't really like this, though. Often, you make your fields private. But now, look, even IntelliJ is saying, no, size is private. And you're trying to access my apple's size field. Can't do that. Python would let you. If I try to run, it's not even gonna. It's gonna give me an error before it even tries to start running. No, size has private access in Apple, and you're trying to access it, can't do that. What we would do is you would write an accessor or a getter. Public, it's public because we want to use it. Int, it's going to return get size. Return size. So now, if I want to access that private field, I call get size. So I use that method, get size. It's kind of like the middleman. Now you might be asking yourself, I mean, that feels kind of silly though, because if you just left it as public, you could have accessed it. But you made it private and then you wrote a method to access it. That feels like you're kind of adding extra steps. But the difference is, if I go back and make this public, I could do this. And when I hit run, I've modified the value of that instance variable. Do we like doing this? Everyone say no. We've made this data mutable. We made it so we can change the contents, the values inside this instance, this variable, this object. We don't like that. Of course, we can do it. There's nothing stopping us. But as soon as you start making your data mutable, you're opening yourself up to 1,000,000,001 different errors. So we avoid doing that. So by making it private, we now have explicit control over how this data can be accessed. It's private. We can get the data with the accessor, with that get size method that just returns the value of size, but there's no way to modify it. It is now impossible to write code to modify this object unless I go and make changes to this object by making that public or something. So this now, as a programmer, I have so much more control. The code that is written using this is so much more likely to be correct because I've enforced how the data can be accessed. And there might be some fields you just never want accessed directly, which we will see in the course. Any questions about that? We're going to go over this public-private throughout the rest of the semester. So if you're not convinced yet, you probably will be in a week or so. Oh, and of course it's mad now because, well, this line of code is saying, well, no, it's private. You can't do that. In Python, even if you follow the convention of an underscore, some asshole could show up and change it and break everything. In Java, it's effectively impossible now, which is fantastic. We like writing code that is robust. We like writing code that is not only correct, but written well. That's robust to change. That's unlikely to be used incorrectly. That's good code. It's not just about correctness. So that's public, private. So example, Python, you can touch me, but if it starts with an underscore, please don't touch me. This should probably be called please do not touch me, because you totally could. In Java, you can touch me. Do not touch me is you can't. You can't even because I'm private. Don't touch me. There. And so just to make things more concrete, everything was fairly abstract with silly names of like don't touch me and some method and some instance variable. Here, temperature converter. This was like the first function we looked at in Python. Well, here it is in Java. Temperature converter in Python, def Fahrenheit to Celsius. Takes some variable Fahrenheit, does the Fahrenheit to Celsius calculation, returns the result. Right? 5 divided by 9 times Fahrenheit minus 30, whatever. You get the result. Well, here it is in Java. We'll make it a function so it's static. It's going to return a double. And remember, double is the word we use for floats, for anything with a decimal, because the conversion is likely to not be a nice clean integer, because, you know, annoying conversions. So it returns a double, and might as well take a double. It takes the double Fahrenheit, and it does the calculation. Fahrenheit minus 32 times 5 divided by 9, and we store that value in a variable called Celsius, that's a double, and then we return that value. Of course, lines 2 and 3 can be combined to one line of code, but whatever. Now, note, you might remember from last semester, I complained a little bit about something Python did that angered the world. So when Python changed from Python 2 to Python 3, they made a number of changes that were really good. And there's one change that has angered people to this day, and they will be angry forever because of it. They did something a little funny. If you write 5 divided by 9, how many times can you get 9 out of the number 5? 0. Plus some remainder, right? But in every programming language, in like all of the most popular programming languages, including Python 2, Any division you do is integer division. If you divide one integer by another integer, the result is
An integer.
an integer. And 5 divided by 9, you're going to think, well, that's 0 point. No, it's not. It's 0.
Does it always round down? Or?
It's always going to round down. It does what they call truncating. You could have 999 divided by 1,000, and the answer is going to be 0. And you're like, but it's 0.999. No, it's not. It's 0. Because it's an integer, and screw those decimals. We don't care. Python followed this rule too, but in Python 3, they changed it so it would automatically change to floating point division. If you divided two integers, Python would be nice and automatically do floating point division. Give you that decimal. So 5 divided by 9 would give you the actual decimal it is, whatever it is. So when they made this change, it broke a lot of code, because there was a lot of code depending on integer division. And suddenly it was giving you a floating point number back. Oh boy, nightmare. Java, like many other of the popular languages, if you did some integer divided by another integer, it's going to give you an integer. It's going to truncate. Any decimal is cut. So if you want floating point division, well, you can do that really easily by just not dividing integers. You divide the floating point numbers, the doubles. 5.0 divided by 9.0 will result in a double. In fact, you could say 5 divided by 9.0 and it would give you a double as well. It does like expanding or exploding, I can't remember what they call it. Just mind this. This is going to be a change that might bite you from Python to Java. If you're expecting integer division to give you a decimal, it's not gonna. The fix though is, well, just divide by, just do the like add the decimals and do the division, and Java will go like, oh, they want the double back. Cool? That's really the only key difference here. Other than that, the code, like look, tiny syntactic differences. The code's the same. Start defining the function, parameters, do the calculation, return the result. It's the same. Which language was I talking about? You don't know. It could be either. Yeah, because they're basically the same. Here's me talking about the division. Comments. Here's comments. Python, a single line comment was like the hash. In Java, //. You want a multi-line comment, you can do /* and then write as much as you want, and then do */ to end that. And remember in Python your doc strings, within the name of your function, you would do like quote, 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 describe the function, list the parameters, what it should return. If you're writing good code, you write your doc strings. Here we write the Java docs. It's * or /*, and instead of under the signature of the function, it's right before. And this is how you do it, slightly different. Just a little different, but there you go. So, convert the provided temperature from Fahrenheit to Celsius. This also demonstrates how to write a Java doc comment. At param Fahrenheit, temperature in Fahrenheit. At return, temperature in Celsius. Describes the function. Anyone who wants to know what's going on in that function reads that. Great. Yeah. Booleans. Yep, they exist in Java. But in Python, they all started with uppercase, and when I say all, I mean the two of them. True and false started with uppercase T and F. In Java, they start with lowercase. If you type in uppercase T, Java's probably going to say, what the hell's this? It's got to be lowercase. Why? Because. And I believe in Python, if you ask the type of a Boolean, it would say bool, B-O-O-L. In Java, we type Boolean, B-O-O-L-E-A-N. That, big difference. Conditionals, if statements, yeah, they exist. Instead of colon indents, we use our squiggles. We use our braces. You'll note, though, that in Java, you need the parentheses around the condition. Because. Python, you didn't need them. You could add them, but in Python, you didn't need them. So if some Boolean, that's got to be in parentheses. So you've got if, open squiggle, whatever, close squiggle, else. If you have an else, open squiggle, whatever, close squiggle. But other than those little syntactical quirks, it's the same. And I'll take this moment to emphasize A lot of times, like, look, you're worried about cheating, good, that's good. But here's one thing that is not considered cheating. Last semester, I remember one of the labs was, I can't remember, I think during the course, we showed an example of creating a student object, and then we had a course object that was a collection of students, right? Right, we had a way to add a student to the course, remove a student, toString for the course, whatever. And then in one of the labs, I made you do effectively the same thing, but it was, instead of students and course, it was like friends and contact lists or something. I can't quite remember. And so many times people in the lab were like, it's the same. Can I just like basically copy and paste and change it slightly to do what's different? And my answer to that is, yes, that's the point. You're supposed to do that. But I noticed on assignment 4, people were a little apprehensive of like, well, I know it's the same as what we did in class, but I don't want to copy that exactly. No, copy that exactly and then change it to do what you need it to do. That's called refactoring. The ability to understand your problem enough to look at a solution to a similar but different problem, take that, refactor it, change it to solve the problem you need, is good. That's good. Now, if you're copying and pasting and tweaking it until you hit run and it finally gets right and you don't understand what the hell's going on, it's not a good idea because then you don't actually know what the hell's going on. But chances are, if you're going through the process of seeing what it is doing, knowing what needs to be different, changing it to work how you need it to work, you understand what's going on. And that is good. We like that. That's a good thing. So if you're like, oh man, how am I going to remember the difference between Python and Java if statements? You're doing programming wrong. You go to Google and you type if statements Java. Oh yeah, that's how I do it again. Boolean operators. You know we had like less than. A less than B, return to true or false, right? Equals equals, are they equivalent? Not equals, yeah, same exact syntax in Java as well. And and or exist as well, obviously. But in Python you wrote and or. In Java we write ampersand and ampersand for and. Pipe for or. That's the key, that's shift, the key above your enter, below your backspace, by the way. Interestingly, I will point out that you actually can do single and single pipe, but when you have and or pipe, it does what they call short circuit, which is often really handy. If I have something, and the first something is false, do I give a shit about what the next thing is? No, because if one of them's false, they're both false. I don't even need to look at the next one. So when you do ampersand, it won't even like look at the next one. But sometimes you might want it to look at the next one, because what if the next one is a function call that returns a Boolean, but that function has a side effect, which you probably don't want to begin with. Just typically you want ampersand, and pipe. And we'll stop there and we'll pick up on loops tomorrow.